This is so important for tests because we're testing one of the new satellites that will be going up into space to help with all of our GPS systems. It's probably going to affect so many lives, not just military, but also commercial alike. So this is like one of the newest type of satellites you could ever see. You are essentially doing something with a satellite that's never been done before. Currently, GPS users are experiencing some jamming in the field. So what we wanted to test here is what they can do to counteract all of those type of things. So we were testing some of the jamming that they might be experiencing and how best to mitigate those issues. We're testing that when the satellite sends out a signal, we can actually receive that signal and it's the correct one. You don't want the satellite to send you back a signal saying that your house is 10 miles away when it's actually like right in front of you. We're checking all of that.
The bath is large enough and has enough infrastructure around it. It's a quiet enough chamber that it protects the aircraft and other GPS users outside of the facility. And so we can't just do this in the open air. We definitely need to have a shielded area, make sure that we keep the energy for our testing inside the building. And so not only did it need to be big, but it also needed to be really well isolated between the test environment inside and everybody else outside. And so across the board, the BAF really fit the bill in a way that no other facility in the United States really could. We're really approaching the very end of our INT campaign. And so it's exciting. We still have a couple more activities to go. We have thermal vacuum testing, where we'll simulate the environment that the satellite will be operating in during the year of experimentation. We also have testing to show that the ground system is compatible with the satellite and that we've designed all the interfaces appropriately and all the configurations are what they need to be so that we can do effective command and control after we launch. And then after that is really a fairly long campaign of testing for our operations crew, so that we have a ready-to-train milestone. And that training involves exercises, rehearsals, tabletop training, and making sure that all of the mission planners and flight directors and operators and the science team are all ready to conduct this experiment after we launch.
And the value of all that is to basically allow for everything to be synchronized together, whether it be airline schedules or whether it be landings and takeoffs at the airports or whether it be military operations. NTS-3 is taking that a step farther because we're using clocks, but we're also doing a demonstration of advanced signals and signal flexibility. And our ability to actually get that job done is predicated upon success in this testing facility.
Each group here, we have U.S. Air Force, U.S. Space Force, AFRL, JPL, had a critical role in the success in testing this NTS-3 satellite.
So it's spent countless engineers' time and a lot of engineering effort to figure out just exactly how to do this testing. And we've ran into so many issues along the way, but with the team we have here, we overcame all of them before roll-in. It's been such a great time, and these engineers just blew me away with how much engineering effort that was done. And we get to see all of our hard work done here and finally get to actually take all of this data that we've worked so hard to get.